The machine you are sitting at right now can probably run a decent AI model, not a toy, something that writes, summarizes, answers questions, and does it in a couple of seconds. No subscription, no account, no internet. The question is only which one, and that comes down to a single number you already have. 3 reasons people do this, and 1 honest reason not to. Privacy. Nothing you type leaves the machine. That is not a marketing promise. The model file is sitting on your drive, there is nowhere for it to go. Cost. You pay nothing per message. Run it all day. And it works offline, on a train, on a plane, when the service you rely on is down. The honest reason not to. The very best hosted models are still better. If you want the strongest possible answer to a hard question, a local model is not it. Local wins on privacy, cost, and control, not on raw capability. So what actually is a local model? It is a file, a big one, but just a file. Inside it are the numbers the model learned during training, the weights. You download it once, and a small program on your computer feeds your text through those numbers and reads out the answer. That is the whole thing. There's no server, no login, no hidden call home. Which is also why it needs memory. The entire file has to be held somewhere the processor can reach it quickly. Which brings us to the trick that makes any of this possible on a normal computer: quantization. Those weights are originally stored at high precision, lots of decimal places. Quantization rounds them off. Fewer decimal places, far less memory. The standard setting you will see everywhere is called Q4KM. It cuts the memory needed by about 75%. A model that wanted 16 gigabytes now fits in around 4.5. And the quality barely moves. That is the part that surprises people. You are not getting a crippled version. You are getting almost the same model in a quarter of the space. Without this, none of what follows would run outside a data center. Now, the number that decides everything, how much memory your graphics card has. Not your system memory, the memory on the card itself. It is called VRAM, and you can look it up in about 20 seconds. Go and check it. This video will wait. 8 gigabytes runs 7 to 8 billion parameter models comfortably, at a speed that feels instant. 12 gigabytes moves you up to the 12 to 14 billion class, noticeably better at anything that needs reasoning. 16 gigabytes gets you to around 24 billion, and there are models built specifically to fit that. 24 gigabytes and above runs the 30 billion class, which is where local starts feeling genuinely strong. If you are buying, 12 to 16 is the sweet spot. Below that you are limited, above that you are paying a lot for the last few percent. Speed is measured in tokens per second, and that number means nothing until you see it. A token is roughly 3/4 of a word. So 40 tokens a second is about 30 words a second, faster than you can read. 10 tokens a second is about 7 or 8 words a second, roughly reading pace. Watch these two fill in. Same text, same moment, one on a graphics card and one without. Neither of those is broken. But one feels like a conversation, and the other feels like waiting. If you're on a Mac, the rules are different, and in your favor. A PC keeps 2 separate pools of memory. The card has its own, and the rest of the computer has its own. When a model does not fit in the card's memory, the leftovers have to travel back and forth across a connection called PCIe, and that connection is the bottleneck. Apple Silicon does not split them. The graphics part of the chip reaches the whole memory pool directly, at speeds several times what that bottleneck allows. In practice, a Mac with 16 gigabytes handles an 8 billion parameter model comfortably, at 30 to 80 tokens a second. 16 is the sensible floor, and unlike a PC, more memory in a Mac directly means bigger models. There is no separate card to run out of, and if you have no dedicated graphics card at all, it still works. A 7 billion parameter model on the processor alone runs at 10 to 25 tokens a second. That is reading pace, slower than you would like, but completely usable for writing, summarizing, and questions. So do not skip this because you think you need special hardware. You almost certainly already have enough to try it. Quick check, your model file is 5 gigabytes and your graphics card has 8. What happens? It refuses to load. It loads and runs fine. Or it loads but runs slowly. Have a think. It loads and runs fine, but But the file size is not the whole story. The model also needs room for the conversation itself, and long chats eat into that. Rule of thumb: leave 2 gigabytes of headroom above the file size. 2 programs do almost all of this, and you do not have to choose carefully. They run the same models. LM Studio is the one to start with. It is a normal application with a window. You browse models, click download, and chat. No terminal, ever. If you have never done this before, start here. Ollama is the other one. It runs in the background and is built to be driven by other software, scripts, apps, automations. Slightly faster, considerably less friendly. The sensible path is both. LM Studio to find out what runs well on your machine. Ollama later if you want to build something on top of it. Now the honest part, because everything so far sounded like an advert. Local models are worse at hard reasoning. On a genuinely difficult problem, the gap between a local model and the best hosted one is real, and you will notice it. They have no live information. They know what was in their training data and nothing since. They hallucinate at least as much as anything else. The same mechanism, the same confident wrongness. And they will not match a hosted model on very long documents. What they are excellent at: everyday writing, rewriting, summarizing, extracting information, answering questions about text you give them, and anything you would rather not put into someone else's system. Which, once you start noticing, is most of what people actually use AI for. So how do you choose without me naming models that will be out of date by the time you watch this? 3 steps. 1. Find your VRAM and pick the size class that fits with a couple of gigabytes to spare. 2. Inside that class, take whatever is currently well regarded. The model names change every few months. The size classes do not. 3. Take the Q4KM version unless you have memory to spare. The current recommendations for each class are in the description, and I will keep that list updated. The logic above is what actually stays true. So, it is a file. It runs on hardware you already own, and quantization is what makes it fit. Your VRAM decides the size class. Tokens per second decides how it feels. A Mac plays by better rules. No graphics card still works. Start with LM Studio. Expect it to be good at everyday work and weak on hard reasoning. And choose by size class rather than by whatever model is fashionable this month. In the next video, I will actually install it, start to finish, where the files come from, what the settings mean, and the 3 errors that catch everybody the first time. If you want that one, subscribe. Thanks for watching.